Hey, this is Joe at graybenchelec. Welcome and welcome back. Today we're doing a teardown on the Union Tube Transistor Tourbender. All right, we got the Union Tube and Transistor Tourbender. These are made in East Vancouver, British Columbia. So with a name like Tourbender, we would expect this is a tonebender derivative. We have two controls, just like a standard tonebender. It's gonna be volume and fuzz, or maybe the other way around. The enclosure is a 1590 BB size enclosure. It's got a nice sort of hammer tone gray finish. Interestingly, on the back here, we have this rubber pad. It's not particularly thick. It's a little, maybe 3/32 or so, a little bit less than 1/8 of an inch. I think that's a bit odd because being a tourbender, what I'm expecting with the name tourbender is that it's going to be sort of a ruggedized version of a pedal. And you would think for a pedal that you're expecting a musician to take out on tour, that you would want the back to be plain so that you could easily stick on hook and loop attachment like Velcro. And it looks like the previous owner did try to do that, but it didn't adhere very well, which I wouldn't expect it to for this sort of porous foam material. And I did check and they do come like this from Union Tube and Transistor. So one nice thing is when you put it on a surface, especially a smooth surface, it's going to want to stick a little bit better. I feel like if you're going on tour, you probably have a pedal board and you probably want to attach hook and loop so you can slap that onto your board and have it stick there. I'm not sure about that call for a pedal geared towards touring musicians. One thing that they have done that I think is a good call though is underneath the knobs here, we have the little rubber O-rings around the potentiometer shaft. And what that does is when you pop the potentiometer on the pedal, or excuse me, when you pop the knob on the potentiometer shaft and give it a little press down, you tighten that down, those rubber O-rings are going to give you a little bit more resistance as you're turning the knob, and that will help prevent accidentally knocking the knob out of position. So once you lock in the settings you want, those are going to stay there unless you probably deliberately come in and change them. They certainly won't rattle out of position. The rubber O-ring is pushing up on that knob and keeping it in place. On the top here we have the Union Tube and Transistor badge. They make two versions of this. The more deluxe version has an actual metal faceplate. These screws here, however, are not holding on this graphic because this is just silk screened on. So these screws must be doing something else inside the pedal, maybe holding up a PCB. On the top here we have our 1/4 inch jacks and our 2.1mm Kobicon style DC jack. Foot switch has a lighter actuation pressure, feels more like the Gorva style or maybe some of those alpha switches that I felt before that are pretty light. 5mm yellow or orange LED with a chrome bezel. Looks to be about it for the exterior. Let's go ahead and crack it open. All right, so here is the PCB for the Union Tube and Transistor Tourbender. So yes, those 4 screws we saw on the top side of the enclosure were in fact mounting holes for the standoffs for the PCB. You can see here that this PCB is designed in a single-sided fashion, so you have just the traces on one side of the PCB and then all the components are mounted to the opposite side. One thing I think is interesting is the way they're attaching the wires to the board. So you can see here, this is the wire for the switch to turn on and off the LED with the bypass function. So you can see here they've elongated the pad for that connection, and what they've done, you can see it here on the other wires, is they're just laying the wire on top of the PCB and then soldering it like that. They're not putting the wire down through the through hole, which I'm not sure how I feel about that connection method. Maybe I'm just speaking out of tradition or something like that, which can be fallacious, but I was always taught to strip the wire long enough that you can put it down through the through hole, and that way as the solder flows into the joint, it flows around the wire through capillary action and connects to the pad on the top side of the board and to the pad on the bottom side. When you lay it on the top, if your solder doesn't flow all the way through that hole, which as far as I can see, it looks like they've done, but if the solder doesn't flow through the hole, then all you're counting on is the through-hole plating connecting the top pad to the bottom trace. You know, that can be one of those things in manufacturing for your PCB that maybe isn't checked very well or whatever. It's something I haven't seen before, and I don't know about the longevity of that, especially on a pedal that's marketed as like a ruggedized pedal. Anyway, moving on, we got some big filter caps here. This is a 1500 microfarad filter cap here, presumably a filter cap somewhere in the power supply. Again, a 1000 microfarad cap also probably in the power supply. These are 16 volt caps, so you definitely would not want to put 18 volts into this pedal. We also have some film caps here, some very tiny electrolytics, which as far as value, it looks like they are 4.7 microfarad at 16 volts, these two little ones here. And this cap here is a 1 microfarad at 50 volts. 3 transistors, as you would expect for a tone bender, and they do have colored paint on top, which suggests some sort of sorting, probably sorting for gain. These are silicon transistors in the TO18 package. This one over here with the pink top is a 2N2907A. Over here with the white top is also a 2N2907A. And brown is same thing, 2N2907A, which I believe is I think that's a PNP? Hold on. Yeah, PNP, silicon transistors here, 3 of them for a tone bender. Our potentiometers here are these little 9mm doodads. I don't see a manufacturer mark on them. The value on this one is an audio 100K, and then over here, this one is a C5K on that one, so reverse log 5K on that pot. The switch, as I thought, is one of the Gorva switches, which are good switches, nice and light, and last longer than the standard blue switches. One of the 1/4 inch jacks here is a switchcraft that has the normally open switch. So when you insert a 1/4 inch jack, it's going to close these two contacts together, like so. You can see it brings those two pieces together. So that's something to check if you're ever inside a pedal that has one of these switches, is to make sure that that's making contact. What exactly that's doing in the pedal, not sure yet. We're going to find out. And then this 1/4 inch jack over here is just one of these standard 2-pole Reassembly type 1/4 inch jacks. These are Hammond branded enclosures. You would expect them to be, being a Canada company. And I suppose that's the serial number down there, BC059TR. All right, so next up, I'm going to trace this pedal out, and we will have a look at the schematic. All right, here is the schematic for the Union Tube Transistor Tourbender. So it does have some similarity to a tone bender, but actually not as similar as I thought it would have been initially, given the name Tourbender. But we do have 3 independent transistor stages. Big capacitors are where we thought they'd be in the power supply here. So we have 9 volts coming in, 150 ohm filter resistor, reverse polarity protection diode, and then that second filter cap. We also have a 1 microfarad film cap also on the power rail. So first off, if this schematic looks kind of funky, the reason is because we have PNP transistors that are kind of upside down. And the reason it's drawn this way is basically because I had to make a choice between 2 different conventions for drawing schematics. And I chose what I see as the more important convention, which is to draw ground at the bottom of the schematic and the power rail at the top. But because we have PNP transistors, which want to have the collector at a negative potential relative to the emitter, they had to be upside down. Make this more clear, I took the schematic here and flipped it 180 degrees vertically. And you can see here, this might look more typical for a PNP transistor-based amplifier or distortion or fuzz pedal. So you have your emitter going down to the bottom rail and collector at the top. So this is like your fuzz faces or your standard PNP tone benders. This is the same schematic as this one here, but the problem with this is we have ground drawn at the top here and the power rail at the bottom. I chose the convention that I believe is more universal, I guess I could say. And we've drawn ground at the bottom here, ground being whatever's connected to the enclosure or the chassis of the electronic device, and then the power rail is the top. This also explains why, even though we have PNP transistors, we do not have negative polarity DC input. We do not have a voltage inverter like a either a 7660 or a TC1044 or LT1054. The pedal runs on positive 9 volts with a negative ground. Other PNP pedals, as you may know, run on positive ground, which is essentially what this schematic here, the flip schematic, is showing, is a positive ground rail with a negative upper rail here. So if you can accept seeing transistors upside down, this schematic I think makes more sense. Going through the schematic here, we have our input. Obviously this is coming from the switch, which isn't shown here. 560K, which is going to set the input impedance of the transistor, 10 nanofarad cap that's going to roll off some high end on the input, like radio frequency, extra stuff you don't need. Transistor amplifier is set up as sort of a self-biasing feedback bias sort of thing. So we're taking the 1.5 meg off the collector here. That's coming over to bias the base. Out of the collector here, we have a 15 nanofarad film cap that is coming over here to our second stage, which sort of sits right here. And this is a voltage divider bias transistor stage. Up here we have our fuzz control, or the right control. They're not labeled on the pedal, but I'm just calling it fuzz control. And that's set up similar to like the fuzz face fuzz control, where you have the electrolytic capacitor connected to the wiper, and this is a reverse 5K connected from emitter to ground, well, to the power rail, but it's in a positive ground pedal, ground. It gets confusing, but it's connected up here to the positive 9 volts, and then the collector is connected with the 12K to ground. 1 microfarad tantalum capacitor coming out of the collector there, and we have another voltage divider biased BJT stage here. This stage is interesting because it's essentially the same as the previous stage, with the exception of slightly different bias conditions for the voltage divider bias, and also the fuzz control is essentially fixed. So if you could think of these two resistors as being part of a potentiometer, this would essentially have the potentiometer locked in a specific position, and then with the capacitor would be the wiper, but it's all fixed. So one mod potentially you could do to this pedal is to replace these two resistors with a potentiometer, and you'd have a second fuzz control. How that would affect the sound, not sure, but that's the fun of modding, is to do stuff, and if it sounds bad, then whatever. Up here on the collector, we have a equal voltage divider bias, which is just going to split the voltage gain or the voltage output in half from this transistor, and that comes out here. 10 nanofarad output cap and standard audio 100K volume output. So like I said, passing similarity to a tonebender, although it has its own unique thing. It has some sort of preset values down here at the last transistor stage, and also the sort of inversion of PNP transistors to not have to worry about positive ground or any type of voltage inverter circuit put into your pedal. It's a simple way to get around those issues. I have seen the sort of turning upside down of transistors like this before, and just like the other pedals I've seen, it requires a lot of power supply filtering, which this pedal obviously has. So it confirms what I've seen before, that you need a lot of filtering when you do this with PNP transistors in a negative ground pedal. All right, so that was a look at the circuit for the Union Tube and Transistor Tourbender. Let's go ahead and put the pedal back together. All right, that's it for the teardown on the Union Tube and Transistor Tourbender. If you have any questions or recommendations for a pedal you want to see on a future teardown episode, let me know in the comments. If you enjoyed the video, I'd appreciate you hitting the like button and subscribing, and hit the notification bell if you want to know when I make a new video. I'm Joe from Graybench Electronics. Thanks for watching.